Every single day we see it up there, right? We feel its warmth on our skin, but we rarely stop to think about it as the violent, incredibly complex, and just absolutely fascinating cosmic engine that it truly is. Today we're taking a deep dive, a journey straight to the center of our solar system, and we're going to completely transform the way you look at our everyday familiar star. Let's kick things off with a pretty staggering fact. Every second, the sun releases more energy than humanity has used throughout its entire history. Just let that sink in for a moment. It's truly incomprehensible. I mean, without this massive nuclear engine, there would be no oceans, no forests, and definitely no human life. We're about to unpack that incomprehensible power and look at the incredible secrets it's still hiding from us.
Okay, let's dive into this. The scale of our star, a giant sphere of fire.
To really appreciate this giant sphere of fire, we have to start by completely shattering our normal earthbound perception of size. At 1.4 million kilometers in diameter, the sheer scale is honestly hard to fathom. Imagine taking the Earth and placing it right next to the sun. Our entire world, everything we know, would look like a tiny, fragile little marble sitting next to a towering, impossibly giant sphere of raging fire. To put that into perspective, you would need over 1 million Earths just to fill the space inside the sun. Over 1 million of our planets packed into this single star. And you know what's kind of crazy? Despite this enormous size, astronomers actually consider our sun to be just an average star. Yeah, there are stars out there hundreds of times larger. But in our cosmic neighborhood, the sun is without a doubt the undisputed king. And that royal status becomes crystal clear when we look at the mass distribution. The sun accounts for a staggering 99.8% of all the mass in the entire solar system. So absolutely everything else, every planet, every moon, every single asteroid and comet makes up just that tiny leftover 0.2% sliver. It's the sun's immense gravity that holds everything captive, keeping our entire neighborhood from just falling apart into the dark. But here's the thing. Section 2, surface paradoxes. The closer we look at this swirling ball of hydrogen and helium, the stranger and more baffling it actually becomes, which leads us straight into the corona mystery. Consider this completely bizarre temperature paradox. Normally you think a heat source gets cooler the further away you move from it, right? Makes sense. Well, the glowing layer of the sun that we actually see, the photosphere, is about 5,500 degrees Celsius. But the outer atmosphere, known as the corona, that actually exceeds 1 million degrees Celsius. How on Earth, or, well, how in space, can heat flow away from its source and get hundreds of times hotter? It's one of astronomy's greatest unsolved mysteries. Scientists think it's driven by violently twisting and snapping magnetic fields that suddenly release enormous amounts of hidden energy. And the mysteries definitely do not stop at the surface. You see, the sun isn't silent. It actually sings. Through a totally fascinating field called helioseismology, scientists study these powerful pressure waves traveling through the star's interior. It basically makes the star vibrate and ring like a gigantic musical instrument. Now, these frequencies are way too low for human ears, but when they're sped up, these eerie, low sounds allow scientists to literally listen to the sun. It works just like an ultrasound, mapping out the hidden inner layers of the star that we could never, ever see directly. Now, bringing our focus back to the surface for a second, we see these defining features, sunspots. These are enormous dark patches, some of which are literally larger than Earth itself. They're created by incredibly powerful magnetic fields that basically block heat from rising normally from the interior. They look black to our instruments, but don't let that fool you. They are still a scorching 4,000 degrees Celsius. They only appear dark because the surrounding fire is just that much hotter. And as we'll see, these magnetic storms are very often the birthplace of something far, far more dangerous. Explosions beyond imagination. Because this is exactly where the sun goes from being a fascinating scientific mystery to a very real, very fast existential threat. Without any warning, those sunspots can unleash solar flares. We're talking about explosions releasing the energy of billions of hydrogen bombs all at once. Let's walk through this devastating 3-step sequence. First, intense X-rays race toward Earth, hitting us at the speed of light in a matter of minutes. Second, a massive wave of charged particles follows closely behind. And third, the impact strikes. This can completely disrupt radio communications, damage our satellites, and pose a massive threat to the electrical power grids we rely on every single day. And sometimes it's not just a flare, it's a coronal mass ejection, or a CME. Picture gigantic clouds of plasma weighing billions of tons violently launched into space at millions of kilometers per hour. These massive clouds only take a few days to cross the immense distance from the Sun to Earth, bringing incredible danger straight to the doorstep of our modern, technology-dependent civilization.
The potential impacts here are pretty severe. An extreme storm could disable satellites, knock out GPS worldwide, and completely overload our power grids. But before we panic, it's important to remember we have a built-in shield. Earth's remarkable magnetic field absorbs a huge amount of this impact. When a CME strikes, our magnetic field deflects the worst of it. It saves our internet and creates those spectacular auroras in our skies. But even so, dangerous geomagnetic storms remain a very real risk that we have to actively monitor and prepare for.
So, how do we actually protect ourselves and solve these lingering mysteries? Touching the sun. Humanity's daring response is the Parker Solar Probe. For decades, scientists dreamed of flying a mission right up to the sun, and in 2018, we finally did it with the Parker Solar Probe. This spacecraft is an absolute engineering marvel. Protected by a revolutionary carbon composite heat shield, it became the very first spacecraft in human history to fly directly into that million-degree outer atmosphere we talked about earlier. And the best part? This mission is actively returning mind-bending discoveries as we speak. It's found completely unexpected magnetic structures, incredibly powerful particle bursts, and vital new clues to that corona temperature mystery. The Parker Solar Probe is literally rewriting what we know about the sun right now, and it's helping scientists accurately monitor space weather so we can prepare governments and industries for those dangerous solar events. A really crucial takeaway here is that the sun's influence doesn't just magically stop at its surface. As the sun constantly leaks particles out into space, it creates what we call the solar wind. This wind forms the heliosphere, a gigantic protective bubble that stretches billions of kilometers into deep space, shielding our entire planetary neighborhood from interstellar radiation. We essentially live inside the extended atmosphere of our star. But like absolutely everything in the universe, this powerful, majestic engine isn't gonna run forever. The sun's final fate. Into the dark. Let's zoom out and look at the deep time of our solar system. Right now, our star is about 4.6 billion years old, which puts it roughly halfway through its life. But in about 5 billion years, that hydrogen fuel is finally going to run out. The sun will dramatically expand into a red giant. Mercury, Venus, and possibly even Earth will be completely engulfed. Eventually, the sun will shed its outer layers entirely, leaving behind only an incredibly dense, glowing core, a white dwarf, just cooling slowly in the dark for trillions of years. Every sunrise feels so ordinary to us, but I want you to consider this beautifully poetic summary. Hidden inside that familiar light is a giant nuclear engine, capable of shaping the destiny of every planet around it. It's not simply a bright object in the sky. The sun is a living, breathing laboratory of physics and the ultimate source of life for us all. The more we discover, the more astonishing our closest star becomes. And honestly, it leaves us with this final, provocative thought. What other astonishing secrets is our closest star still hiding? Thank you so much for joining me. I really hope that the next time you step outside and feel that warmth on your face, you look up with a renewed sense of absolute wonder. Keep questioning and keep learning.